But as a start, we want to remind you about what we said in the last period. We said in the last period that you can calculate both acceleration and velocity using this law. Okay. For velocity, we said velocity equals a change in position over time. We can rearrange this one to start with final position equals initial position plus Vt. Assalamu alaikum. We'll start from again. Okay, no problem. We said we can calculate velocity from this law. Velocity equal change in position equal change final position minus initial position. Okay, over time we can rearrange it to become xf. xf will start with xf equal xi plus vt. Also the same thing we can do for acceleration. So the acceleration equal change in velocity over time, and the measuring unit is meter per second squared. Velocity is measured in meter per second. We arrange the equation we already did last period. So Vf equal Vi plus At. And here we can, the graph, we can, when we write position versus time. Okay, if you have a line, the slope of the line, will equal to, the slope equals to average velocity. Average velocity. Okay, and the absolute value of slope, these two lines, equals what? Speed. For acceleration, we draw velocity with time. And the same thing by calculating what slope, you are calculating what acceleration. Okay, so this is the summary of the previous lesson and what we talked last period about acceleration. In your book here, I hope you downloaded this PDF. Okay, all the words, all the statements I said or I focused on, they are highlighted here. Okay, and we said if we have two velocities or in the form of vectors and want to calculate acceleration, we just follow the law as previous, right? So let's do it in steps together. The first thing, if you have this Vi and this Vf, okay, to find the acceleration, the law said accelerations equals Vf minus Vi. Vf minus Vi over time. So we have to reverse Vi because Vi in the law is what? Negative. So we will keep Vf the same, but we will reverse the direction of Vi. This will be Vf, this will be Vi. And we have to put over each other. Why? Because to show us the difference between the two lenses. To show us the difference between these lenses. And this will be the delta V. And what is the direction of delta V? We took from vector addition the direction of the resultant now. Okay, the direction of the resultant will be the direction of the bigger one. The bigger one here from the lens, it's what Vf, so it will be the same direction as Vf. Vf, when we divide over time, we can have what? Acceleration. So the acceleration will be in this direction. Okay. Now, if you look to Vf in the positive direction, acceleration also in the positive direction. So we can summarize that if the acceleration and velocity are in the same direction, if acceleration and velocity are in the same direction, if velocity is positive, acceleration is positive, and the velocity is positive, so it means object is speeding up. Okay? And also if acceleration is negative and the velocity is negative, also it is what? Speeding up. Mister, it is negative and negative. Yes. Because I said if they have the same direction means acceleration in positive direction, velocity in positive direction. Here acceleration negative direction and the velocity is negative direction. How could this happen? Okay, if this was our coordinate system, we say this positive direction and this negative direction. If the car is moving in this direction, okay, if we have a car and the car is moving in this direction and it increases its speed in this direction, so both velocity and the acceleration are in positive direction. But maybe the car is moving, this is the origin, to the left or east or west. So the velocity is negative and also the acceleration is negative. Okay, so both velocity and the acceleration have the same direction, negative, negative, positive, positive. So it means object is speeding up. Okay, but when acceleration and velocity have opposite direction, it means could be this one negative, this one positive, or the opposite. The acceleration may be negative and the velocity may be positive. So in both cases, what happened to the object? The object is slowing down. Okay, how could this happen? Like when if you are driving a car, okay, and you find that if you are on a road and this is your car, and you find a traffic signal, you see that the light is red. So what you have to do? You have to stop because the light is red. So you will use the brake. So at the beginning, the velocity was in this direction, but now you want to use the brake. The brake is doing what? Is trying to decrease the speed of the object or trying to move it, make it move backward. So the action of brake, you can imagine it is drawing your car in the opposite direction. So the acceleration now is in the opposite direction. Acceleration is in opposite direction. Okay, it means here velocity is positive, acceleration is negative. Okay, and you could happen if this is the traffic signal and this is the car. So your velocity is here to the negative, and use your brake is drawing you back. So it means acceleration is positive because it is in positive direction. And remember, when we said about negative and positive, we said it refers to direction. So again, when both acceleration and the velocity are in different directions, so it means object is slowing down. If they are with the same direction, it means object is speeding up. Okay? Now we have another idea. Before we move to another idea, do you have a question here, Shabab? Do you have a question for this point? We already, until now, we just trying to summarize what we said last period. This also we said. Okay, also the lost time graph. We said all of these things. Okay, just new two ideas. This graph. When you have a velocity time graph. If you have value here, let's take the line A. If this value is, let's say 20, and let's just make 10. A and E, line A and line E, they are horizontal, right? Horizontal to the origin. What does it mean? It's the object moving, or it has a velocity of 20, and it is constant velocity. Constant what? Velocity. Why I said velocity? Because 20 is not increasing or decreasing, and the direction is not changing So no change in velocity. So it means what? We have constant velocity. What about acceleration? Who can tell me what is the acceleration for this line? Rashid. Rashid. Where did he go? Okay, Omar.
Assalamu alaikum.
Alaikum salam.
The acceleration is zero because there is no change in velocity.
Okay, excellent. No change in velocity, it means acceleration is zero. Another reason that if you want to calculate the slope for this line, what is the slope for this line?
Zero.
Zero. So it means acceleration is zero for two reasons. Omar said the first one because we have constant velocity. The reason number two, there is no, so the slope also equal to zero. The same thing we did for this one, the same like line E. Line E also have V is constant, okay, and also acceleration is zero because there is no change in velocity, and also if we calculate the slope will be zero. Okay, pay attention. East here is this one direction is east, this positive direction, this west is negative direction, this what? This is the origin. Okay, so we can make right, left, or up and down like what he did here. That what we care about is which one is positive, which one is negative. Okay, come to this line, line B. Line B, what is the velocity? Velocity is increasing. Velocity is what? Increasing, right? So we put what? We have a positive velocity. We have a positive velocity. And so the acceleration also is what? If we calculated the slope for the line, the acceleration will be positive, right? So acceleration also is positive. So velocity is positive. Why velocity is positive? Because from 0 to east, we are in the positive region. We are in the positive region. Pay attention for this. From 0 to east, if we have a car and this car is moving with a velocity, it is moving in what? In the positive region, right? So the velocity is positive. If we calculate the acceleration from the slope, you find the acceleration is what? Is positive also. Okay? So it means this object is what? Moving with increasing velocity. So we have here a constant acceleration, and the acceleration is positive like the velocity. Okay, if we look to line C, who can tell us line C? Line C, شباب. It's tricky before I say it's tricky. Okay, مساء. You dropped your hand. Okay, مساء.
Sorry, mister.
Okay.
I will try, okay?
Okay, no problem.
First, where's line C? Oh, line C is the deceleration.
Now, we said we will not say decelerating. Forget this word, lower.
So it's negative, negative.
We don't have this word in our curriculum. If you use this word, it will be wrong. Okay?
So it's negative.
Yes, excellent. Excellent. What is negative? Total acceleration.
What?
Which one is negative? Velocity or acceleration?
Wait. Velocity.
Rajul. Here, the car is moving in the positive region.
I guess the best sign.
Yes, the velocity is what? Is positive, right?
Yeah.
But I said why we choose velocity positive because above the line,
yes, I
above the
understand.
line, yes, yeah. this line represents velocity, right? So above the line, all velocity are positive. Okay?
Yeah.
So Shabab, how can we know that velocity is positive or negative? We have a line. Above the line, velocity is positive. Down the line, velocity is negative. But what about acceleration? You have to look to slope. Okay? So here, the slope will be positive or negative?
Positive. Velocity.
Acceleration. As it for velocity, the line.
The slope will be negative and the velocity will be.
Excellent. The acceleration is negative because the slope will be negative. Now what's happening? Now what is happening to this car or this object? It is what? Slowing down or speeding up?
slowing down.
Slowing down from the line, it is slowing down. As a proof, if we calculate slope, we find the slope is what is a negative, right? So he is, as you can see, he's moving from a value here and will reach 0, right? So you are right. He's moving in positive direction, but he is decreasing its velocity, so it means the acceleration is negative. Okay, can we do line D? Another one, Shabab.
Yes.
Line D. Thanks, Abza.
Okay.
Another one, raise your hands. So,
Assalamu alaikum.
Alaikum salam.
Yes, hello, Mr.
Okay.
Line D,
Line D.
negative velocity.
Okay. Before we start, how many sections in line D? Or how many regions? How many regions on line D?
2.
No, 3.
Can you locate them, Mr.?
Yes, I can locate. That's it. So I have to look, right? So if you look here, in this part, he is in the negative region, right?
Yes.
Okay. And at this point, he is at the origin. It means its velocity is what? 0. So it stopped in this place.
0.
And if we moved to this part, it is in the positive region. Right? So how many regions we have?
3.
3. Negative region
and neutral.
and 0 and positive region. And all of this related to velocity. So here the velocity is negative. Why? Mr. The line is going up. Yes, but we said the direction, look where you are. You are in the positive region or in the negative region. Okay, so down the origin, the velocity is negative. Above the origin, the velocity is
Positive.
positive. Excellent. What about acceleration?
Acceleration is positive.
Look here for this one. Excellent. About acceleration. If you calculate acceleration, we find it is what? Positive. So as a proof, as we said,
Because Mr.
velocity and the acceleration, let me talk. Velocity and the acceleration have opposite sign.
Right.
So as you see, it is moving to the origin, like you are moving to a traffic light, so you have to stop, right? So at this point, the car stopped. Okay, so the velocity here is what? Where we have intersection, the velocity here is 0. Okay, continue. He is moving from 0 velocity, is increasing its velocity, and is moving in the positive direction. So its velocity is positive. And if we calculate slope, so you will find the acceleration is positive. So it's a proof he is increasing or speeding up. Everyone, everything is clear?
My answer is correct, Mr.
Yes, alhamdulillah.
Thank you, Mr.
شباب, we have to repeat. Clear. Okay. Look, if we are velocity for velocity, if the line is up, so it means velocity is, so we have positive velocity when the line is up. We have negative velocity if the line is down. Okay? 0 velocity if the line is at the origin. Okay? If the line is at the origin, like this point, intersection, or this point, Okay? It stops here. Here it stops. Here is starting to move, so the initial velocity is 0. Okay? So velocity could be positive if it is moving. If we find the line, this is your judgment line. This is the judgment line, the 0 line, the origin. If the line is above, so velocity is positive. If the line is down, so velocity is what? Negative. So all of this, the velocity is what? Positive. Velocity is positive. Velocity is positive. Velocity is positive. What about line down? No, velocity is negative. I hope it's clear for velocity. Okay, when we look to acceleration, look to the slope. Look to the slope. Okay? Here, the slope is 0, so acceleration is 0. Here it is going down, so the slope is negative, as we said before. Here it is going up, the slope will be positive. Okay. Here also it is up, so positive acceleration. Here the slope also will be positive, so acceleration is positive. Here the slope is 0, so acceleration is 0. Now it's easy. شباب, everything is clear? Do you have a question? Do you have a question? Okay, but I have questions. Okay, so are you raising your hand or yes? Okay. Yes, so
Sorry, Mr. I want to lower it. I raised it. Sorry.
البراء. البراء.
Yes, mister.
Yes, how are you?
I'm fine, thank you. How are you?
Everything is okay?
Yes.
Okay, did you understand why velocity is positive, why velocity is negative?
Yes.
When velocity is positive?
When it's from 0 to when goes up.
Excellent.
And
excellent. And
complete.
Yes, yes.
And from to be negative when it's up and goes down.
When it is from 0, down
Yes.
0, down 0, it will
Down
be
0.
negative. Yes. Up 0, it will be positive.
And
what about,
straight line, it's a straight line, it's 0.
So when we need acceleration, we need to the slope. This straight line, don't say straight, it's horizontal to the origin. This is the origin of 0, it is horizontal to the origin, right? So the slope is 0,
Yes.
so acceleration is 0. For this line,
Because
acceleration is
it's
positive.
constant speed.
Yes. And here, acceleration is positive because the slope will be positive. Here, the acceleration is negative because the slope will
Because
be
it goes down.
negative. Yes, excellent. Thanks, Amara. So, raise your hand again.
Mr. How we know that it's moving in a constant speed?
Yes, here look to this value. I put before a value 1. Suppose this value is 20.
Yes.
يعني this here مثلا make 10, this one 30. The velocity is moving up or down, but this one is decreasing velocity, right? Here it has a value, here it has a value, here it reaches 0. This
Yes.
one, B, it started from 0. Here you can say it reached 8. Here it can reach 10.
Mr.
So the line is increasing or decreasing, going up or going down. So we have a change in velocity. But if the line is horizontal to 0, so it means the time is passing, and if you are driving your car and you just not changing, the speedometer reads 30 kilometer or 40 kilometer, and you didn't change. It's like this one.
Okay.
Okay. And Shabab, do you have any question for this point?
Yeah. Thank you.
Okay. The second thing we want to talk about is how could we have acceleration when we change direction? You can see from this line, he's in the negative region, right? Then he at 0, then he moved up to the positive. So he changed direction. Okay, so here it was negative velocity, we have here positive acceleration. Here positive velocity, we have positive acceleration. Because it changed direction from negative to positive, so we have what? Acceleration also. But can we do this in a problem with number? Yes. Let's look here. Yes, look to this problem, Shababin. In the average acceleration, he gave us a law. Here, he give you, suppose you run wind sprints back and forth across the gym. You first run at a speed of 4 meters per second toward the wall. toward the wall. So let's draw what he's saying here. If you have a wall, okay, this is the wall of the gym. You are trying to reach this wall. okay, with a velocity equals to 4 meters per second. Okay, you are moving towards the wall. Then 10 seconds later, your speed is 4 meters per second as you run away from the wall. So it means you change in direction. You are going back, right? What is your speed? 4. The same speed. 4 meters per second. And the time taken, okay, it gives us the time. It's 10 seconds. So the time here is 10 seconds. So could we have acceleration, Mister? The speed or the magnitude of the velocity didn't change. So, but pay attention, we changed the direction. Can we prove this? Yes. If you look here, we say velocity acceleration equals Vf minus Vi. And exactly over time. The time here you give 10 seconds. Look here, Vf minus Vi. So what is the value of Vf? This one. What is Vi? This one. So this is Vi. So this is the initial velocity when he started to move towards the car. And this is the final velocity when he left the wall. Okay. Look to the law, it's Vf minus Vi. Look here. What is the value of Vf? It is 4, right? But pay attention, we changed the direction. If this direction was positive, now he is moving in the negative direction. It changed. It was more, if we talk to the wall is positive, direction to the wall is positive. Now the direction away from the wall is what? Is negative. So Vf will be 4? No, Vf will be minus 4. Look here. Then 10 seconds later, your speed is 4 meters per second as you run away from the wall. So now he is giving us, for the whole statement, is giving us velocity. He gave us speed or the magnitude, and he gave us the direction. So when you write, you must show magnitude and direction. So when we replace Vf with minus 4, and the law is said minus, okay, minus, and what is Vi? Vi is 4. And what is the time? The time is 10. Minus 4 equals minus 8 over 10. Minus 8 over 10 equals minus 0.8. And the exact it is what? Meter per second square. So it means he is now accelerating in the negative direction. Okay, so it's a proof that if we have a change in direction, we could have what? Acceleration, even if we are moving with the same speed. But what is the difference? This one is in positive direction and this one is in negative direction. Do you have questions for this point?